Hi guys. So today we're going to be starting off with the chapter trigonometry. All right. Now, before we get into it, I just want to say that this is a very important chapter and a very easy one to say. And the reason why I said that it's so important is because it's going to add value to when you're solving questions or when you're doing questions for mensuration or for circular measure and stuff like that, right? So let's get on with it. So the first thing that we need to know is what's trigonometry, right? So trigonometry is basically it's a branch of mathematics where you study the relationship between your angles and the sides, but once again limited to your triangles. Right now we're going to study two different cases where we've got right angle triangles and where we've got non-right angle triangle or oblique triangles, basically, right? Where you're supposed to find out the sides, where you're supposed to find out your the angle and stuff like that, right? So there are different approaches, different ways, different methods that we're going to be studying. Okay, so so what's trigonometry again? It is where we study the relationship of the sides or the angles of triangles. Alright, now the first thing that you're expected to know is what's Pythagoras theorem. What is Pythagoras? Theorem, right? Now Pythagoras theorem is basically is something that you use when you've got a right angle triangle, all right, and you are only concerned with the sides. All right, so let's suppose I've got a right angle triangle that looks like this. Okay, now this sign right here, this little box right here is an indication that my triangle is a right angle. Alright, or it is 90 degrees. Okay, now Pythagoras theorem says that that the square of the hypotenuse is equal to the square of the perpendicular plus the square of the base. Right now, what is the hypotenuse, what is the perpendicular, what's the base? These are basically names that we have for the sides. We need to first identify which side is which, so let's do that. So the side which is opposite to the 90-degree angle will always be the side hypotenuse. Alright, this side right here will be your base, or in other words the adjacent side. Alright, and this side right here, which is standing upright, is going to be your perpendicular, also known as your opposite side. But right now let's just keep it to perpendicular, let's just limit it to that. Right now Pythagoras theorem states that that the square of the hypotenuse is equal to the sum of the squares for your perpendicular side plus your base. Okay, so just in let's suppose you've got a situation where the examiner has given you the hypotenuse side. Actually, let's say the examiner has given you the perpendicular. Okay, the examiner has given you the base and is asking you to find out the hypotenuse. Alright, he's asking you to find out this side, which is the hypotenuse side. Right, in that case, what are you going to do? Simply, let's suppose the perpendicular is 5 and this guy right here is 3 centimeters. Okay, what you do over here is that you're just simply supposed to plug in the values in this formula, which is hypotenuse square equals to perpendicular square plus base square. Alright, let's do that. So perpendicular, as you know, is 5, so this will be 5 squared plus base, which is going to be 3 squared, equals to the hypotenuse square. Right, the next step will be that you take a square root on both sides Alright, you can solve this. The square root will cancel off the square, and on the other side you get 5 square, which is 25, plus 3 square, which is 9, which is going to give you an under root 34, which is going to give us 5.8 something, 5.83 or something like that centimeters. Alright, now this 5.8 centimeters, as you can see, is greater than the other two sides, which were 5 and 3, right? So the triangle looked something like this. Alright, so this was 5 and this was 3, and after we've done the we've done the calculation, we found out that this was 5.8 centimeters. Now one thing to observe here is that these two sides, the perpendicular and the base, right, they will always be smaller than the hypotenuse side. Okay, always remember this, that the two sides, perpendicular and the base, will always be smaller than your than the hypotenuse, than side hypotenuse. Okay, now once again, over here was more of a simple scenario where we just had to find out the hypotenuse. In a situation where, let's change this up a little bit. Let's say I have, okay, let's say I've got the hypotenuse side, I've got the base, which is, let's say, 4. Alright, and I need to find out the perpendicular side. Okay, how would you do that? You'll use the same formula, equals to perpendicular square plus base square, but you've got to rearrange it according to the question, right? Since you've got to find out this guy, you'll make perpendicular as the subject. Now how do you do that? You'll take this guy on the other side, which will make your equation something like this: minus base square equals to perpendicular square. Alright, now you just simply plug in your values, which are, so the hypotenuse is 6, so 6 squared minus base, which is 4 square equals to p squared, perpendicular square. So perpendicular, you'll take a square root on both sides again, so this is going to cancel it out over here, and this becomes 6 square, which is 36, minus 4, which is 16, which is going to give you 20 under root 20, I'm sorry, yeah, and this can give you the perpendicular side as 4.47 or 4.5 centimeters. Alright, now once again, without doing any further calculations or without doing anything else, I can actually very confidently say that this answer would be correct. Why is that so? Because one of the things is the hypotenuse. If my answer was, let's suppose, if it was p equals to 7 centimeters, right, let's suppose, right, I would automatically be like, okay, this is not possible. Why is that? That is because the hypotenuse is 6 centimeters, so whatever the value of the perpendicular or the base is, it is supposed to be less than 6 centimeters, right? So it automatically just completely get rid of this value and say that, okay, I've done something wrong. Alright, so that is basically what the Pythagoras theorem is. One thing to note is that the Pythagoras theorem is only used when you've got right angle triangles. Alright, and only used when they are talking about the sides, and they're asking you to find out the value of your sides. Okay, no angles, nothing, only the sides. Alright, and they're only talking about 3 sides. They'll either give you 2 sides and ask you to find out one of your sides, and yeah. Okay, now we've got another case where this is basically the real deal, where you are supposed to find out the sides, or in some cases they might ask you to find out your angles as well. Right, now let's suppose you've got a right angle triangle, and in the question they're talking about 2 sides and 1 angle. Alright, they're talking about these 2 things. Now what do I mean by that? They can either ask you to find out one side, they can give you one side, and they can give you one angle over here. Alright, or they can either give you the they can either give you two sides, the value of two sides in the question, and ask you to find out the angle. Okay, now this is where you do trigonometric ratio. This is where trigonometric ratios come into place. Alright, now trigonometric ratios, we've got three main trigonometric ratios. We've got the sine, we've got cos, and we've got tan. Alright, now these three will only be used when you have a right angle triangle number 1, okay, that is the first requirement. Alright, and when you're supposed to when in the question they're either talking about two sides and one angle. Could be different cases where angle and sides are supposed to be found out, but yeah. Now first up, in trigonometry, just like in Pythagoras Theorem, we were only concerned with the sides. Over here we're concerned with two sides and one angle. Alright, now let's suppose this is the angle theta. Alright, and this is supposed to be once again the hypotenuse side. Alright, now the side which is opposite to the angle in the question will be called your opposite side, or the perpendicular side, which we did earlier on. Okay, and this side will be your the base side, or the adjacent side. Alright, now we're going to be using this more often in this case, and we'll be using this opposite word more often in this case. It's alright. Now, so if in a situation where you're supposed to find out okay, let's see. So what is sine? Sine will be when you are talking about one angle and they're talking about one opposite side, and they're talking about the hypotenuse side. Okay, if in the question they have they've mentioned the opposite side, they're talking about the hypotenuse side, and they've given you an angle, in that case we'll be talking about, or we'll be using the formula for sine. In a situation where the examiner says that you've got an angle, we've got the adjacent side involved, and we've got the hypotenuse side involved, in that case we'll be using your cos. In a situation where we've got tan theta, we've got the angle, we've got the opposite side, and we've got to mention about the adjacent side, we'll be doing your we'll be doing your tan. Okay, now these are the three trigonometric ratios that we have. An easy way to remember this would be to go about it like this. So okay, now this guy right here is telling you about sine. This O says that this is the opposite side, and this H says that this is the hypotenuse that we're concerned with. In this case, it's going to be cos, the adjacent side, the hypotenuse, the tan, the opposite side, and the adjacent, and so on. Alright, now once again, this will only be used when you've got a right angle triangle, and will only be used when you've got to find out your either the side or the angle. Two sides and one angle is involved. There you go. Now I personally feel like this is the most easiest of all. I mean, you just need to the only difficult thing over here that people do find difficult and people do get concerned about a little bit is going to be where they have to identify the sides. Once you've identified the sides, once you know how to plug in those values, then it's like it's a smooth sailing boat from there. Okay, now so let's do a sample question. Let's say, alright, so let's suppose we have a question that looks like this. Okay, this is a right angle triangle. This is 4 centimeters, this is 7 centimeters, and they want you to find out this angle x degrees. Alright, or it can be theta, whatever works for you, or whatever the question is asking for at that point. Okay, now in this case what you do is you quickly the first step will be to identify which sides have been given to you. As you can see that this side right here is your hypotenuse side, this side right here is the opposite side which has been given to you. Now you're going to recall this part of SOHCAHTOA. Okay, now as you can see that they have mentioned the opposite side and they have mentioned the hypotenuse in the question, and they want you to find out your theta over here, or the angle. So which means that since these three values have been given to you or are being talked about in the question, you'll be using sine in this specific question. So sine x degrees or theta, since it's the angle, will be equal to the opposite, which is 4 divided by 7. Okay, you do the math after that. So you'll divide 4 by 7 next. So when you do 4 divided by 7, you get sine theta or sine x will be 0.57. Now in order to further solve this, you'll have to take an inverse, or basically in other words you divide both sides with sine. Okay, and when you do that, this is what you get: x degrees equals to sine inverse of 0.57. It's going to give you 34.7, I would say, degrees. Okay, there you go. So x right here, the value of x is 34.7 degrees or 35 degrees. Okay, that is basically how you will be solving questions for the trigonometric ratios, right? So just like we had the opposite and the hypotenuse being talked about and the angle being talked about in the question, they might ask you to they might just give you the opposite and the adjacent side, and you will have to find out the angle with the help of tan right here. Okay, and similarly the same goes for cos. Now the only magic the only thing that will be counting over here towards solving your questions is how you identify the sides. Once you've identified the sides, once you've identified what the examiner, what the question is asking of you in the question, it gets very easy, because you'll just have to refer back to this table, to this small abbreviation kind of a thing, and that's how you will easily be able to solve questions for trigonometric ratios. Okay.